In the previous video, you learned about tautology and contradiction. Tautology is any statement true for all input combinations for its compound statement. I also mentioned that tautology is used to identify logical equivalence. It means two compound preposition is logically equivalent if they have the same truth value. Suppose P and Q are two compound statements, then P biconditional Q must be a tautology. A logical equivalence is denoted as P equivalent to Q. The symbol is not a compound statement but shows logical equivalence, meaning both P and Q gives a tautology if we apply biconditional rule to them. Truth table is best way to recognize logical equivalence because we can list all the outputs for a compound preposition. Then compare the results of compound prepositions. If the results are same, then it is called logical equivalence. There are several logical equivalences. We take few of them as examples and verify the claim. The De Morgan's law is a well-known logical equivalence, which is negation of P or Q is equivalent to not P and not Q, and negation of P and Q is equivalent to not P or not Q. Let us check the logical equivalence of De Morgan's law using truth table. First, we need to construct a truth table for De Morgan's first law. Both De Morgan's law use two variables, which means we have 2 raised to 2 equals 4 rows in the truth table. The columns are P, Q, not P, not Q, P or Q, not of P or Q, and not P and not Q. Enter truth values for each column, starting with column P and column Q. The values for not P and column not Q is exactly opposite of column P and column Q. Now enter truth value for P or Q. In this column, enter true for any value that is true in P column or Q column. The not of P or Q is negation of P or Q column. Enter values in this column. All entries are opposite of column P or Q. Finally, evaluate not P and not Q and enter truth values. Now, if we compare the results of not P or Q and not P and not Q, we find that both are same and these two compound prepositions used as biconditionals will be a tautology. Therefore, De Morgan's first law is a logical equivalence. Similarly, draw truth table for second law. First, make table with columns for P, Q, not P, not Q, P and Q, not of P and Q, and not P or not Q. Enter values for P, Q, not P, and not Q. Then evaluate P and Q, which is true. Whenever column P value and column Q value is true, all other entries are false. The not of P and Q is negation of column P and Q, so all entries are opposite of column P and Q. Finally, evaluate the values for column not P or not Q by looking at column not P and column not Q. If any one of the column from not P or column not Q is true, the not P or not Q column is true, else it is false. The results from not of P and Q and not P or not Q shows that rows are same and it is a tautology. Therefore, second De Morgan's law is also logical equivalence. Let's check the logical equivalence for compound prepositions with 3 variables. We do this with truth table for distributive laws. The distributive law has 2 cases: distribution of disjunction over conjunction and distribution of conjunction over disjunction. If P, Q and R are 3 statements, then the distributive law is P or Q and R is equivalent to P or Q and P or R. This is the first law of distribution of or over and. Similarly, the second law states that P and Q or R is equivalent to P and Q or P and R. There are three variables P, Q and R, which means 2 raised to 3 equals 8. Therefore, the truth table has 8 rows. If we construct the truth table for first distributive law, then the columns are P, Q, R, Q and R, P or Q and R, P or Q, P or R, and finally P or Q and P or R. Enter values for P, Q and R. Then you evaluate the truth values for other columns. The result of P or Q and R is same as P or Q and P or R. And when I apply the biconditional rule on both columns, we get a tautology. Therefore, distributive law is an equivalence. I have drawn the truth table for second distributive law already, and the result is same for column P and Q or R and the column P and Q or P and R. It is also a tautology if we apply biconditional on both columns. The conclusion is that the distributive law is a logical equivalence. There is a long list of established logical equivalences which I will verify one at a time. The link to list of logical equivalence is given in the description below so that you can memorize them, because we are going to need them for constructing new logical equivalence in the future.